number 1, okay? Which is 3x squared minus 19x minus 14. And it says what? Factor completely, correct? Mm-hmm. So, there's a different method that we can do this. AC method or trial and error method. A lot of times, students just go ahead and separate the two, and I'm going to go ahead and do the AC method, which is the one. It's easier, right? Because we get what? The signs correctly most of the time with this one. So, AC, right? So, A, B, C. So we're just going to pull our numbers, right? You can pull your signs with it at this time, or you can do it at the end. You can just remember that it's going to be 3 times negative 14, okay? So 3 times negative 14 will give you negative 42. And now, this is your term that you need to find in order to get to the middle, correct? Yes. Right? Yeah. Okay. Because remember, we don't use this here to set up grouping, because that's what the AC method is. It's a grouping method. We need now 2 factors of negative 42 that make up the middle term. So now we're going to find what times what gives you 42.
6 times 7.
6 and what?
6 times 7.
6 times 7.
Yeah. Positive and negative. 6
times negative 7, right? Now when you subtract these, does it give you negative 19? No, right? That gives you negative 1. So we also have other factors that I'm just going to throw over here, right? How about 2 and 21? That gives you 42. And when you go ahead and take the difference, that's going to give you negative 19. Okay? Now, we need to rewrite this. We need to rewrite this, and we already used this portion in our AC method. So we're not going to use it again, so we just bring it down. Did we use this at all? No. This is the part that we need to split with the factors you just found. So now we're going to go ahead, rewrite what you just found. And the same thing with this. Since you already used this for this method, you can't use it again, so you just bring it down. That's the importance with this. Okay? So now you have your 4 terms, which is your grouping method, which you said earlier. You split it right in the middle. And we take out our 3x, right? We left x minus 7. Plus 2, and we're left with x minus 7. And you have x minus 7 times 3x plus 2. And that's why we tend to favor this one. Because once you get to this part, you can easily see your factors. Now, it's not written this way for your answer key, but you know that what? You can just rewrite it, right? You can rewrite it like this, and it represents the same answer.
In that case, what we would do is FOIL?
We FOIL to double check it to see if we get back that. Okay. Now you have your second one, right? We're looking at, before we split it in the middle like we did this one, because we have 4 terms again, you need to carefully look at each one. Because what do you notice each one has?
Different variables?
Different variables, but one of them has a common variable. Don't they each share an R?
Yes.
Yes. So since they each share an R, isn't that our basic factor that we've learned first? Do you remember what that is?
No.
Our GCF. Right? We do so much factoring, we forget about the basic one, our greatest common factor. So we can take that out and rewrite our terms. Hi, how are you? We just got started. So we are on number 2. And I just stated that with number 2, before we start our grouping method, because since they are 4 terms, each one shares an R. So we factor that out first with the GCF. Okay. Now, we're going to do as we did this one, right? We're going to split it right in the middle and do our grouping method. And keep bringing down your R at the end. So that way we have to remember we have to bring it down at the end. So, what do they share each one in common here? S. And you're left with 2 minus 3t. Do we see that? Okay. How about this one? What can we take out for GCF here? 4. Let's take out the negative 4 with it, right? Always remember to take out a sign with these. Okay. So you see how this one and this one have a common factor of 4? We can't take out a t because this one doesn't have a t. So we leave the variable alone here. So you're left with t minus, right? Did I write this correctly? That should become positive. 3t. Yeah. I want to make sure. Are we plus? No, this one's plus.
Or would the 3t would be plus 3t since it's a negative 4?
That's what I'm saying. I wrote this one incorrectly at first. So now, we have a common factor, right? T plus 3t. We just take that out, write the remaining ones. But if you leave it just like this, you're incorrect. Because what did we take out first? The R. So remember to bring this down and put it in front of your answer. Okay? Because that was your first factor. So don't forget about that one. Where?
No.
You're good?
Yeah.
You sure?
Yes.
Okay. So yeah, the important part was that one was seeing that you can take out an R first. Okay? And then you can go ahead with your grouping. Okay? So now, for this one, there's something special about this one, right? The variable is 2 the cube, and it's a sum. So we kind of need to remember our formulas. Our sum of cubes, right? So we have our a to the third, b to the third. It's going to automatically factor. You take the cubes of each. And then you're going to have another quantity of a squared minus ab plus b squared. Okay? That formula helps us factor anything that we have. This term to the cube, this term to the cube. And when we have 2 terms, right? Now looking at this, well, this is not to the cube, the coefficient, and this is not to the cube. But what happens? They share a special GCF, just like here. We have a GCF of 2. So let's take that out. And when we divide 54 by 2, I believe that's 27. And now 27 is a special cube. Right? That's one of the ones that we should get into the habit of remembering. What times what gives me 27? 3, exactly. So now, I'm going to leave this off to the side, kind of like how I did my R, but I have to remember, I have to put it at the end, okay? So I'm going to take the cube of my first, take the cube root of my second. So that's this part here. Okay? Now I have to fill in my second part. I have to square my first part, so that's going to give me x squared. This tells me my sign automatically. the second part is just a multiplication, correct? When we have letters together. So I have to multiply whatever I have here times here. So I'm going to multiply 3 times my x. So it's 3x.
That's always negative?
This part, yes, if you have a sum of cubes. If you have a sum of cubes. Then you're going to square the second part. And I'll give you plus 9. That's that part, but we're not done, right? We have to bring down our 2. So put the 2 in front. That's if you have a sum of cubes. You have another formula that you need to remember if you have a difference of cubes. Okay? So go back and remember those notes, okay? Because that'll help you in that scenario. I'll write it down for you. So that way you can see, if you remember 1, all you have to do is remember how the signs are for the other one. So if you have a difference of cubes, you give in this scenario, right? A to the third minus b to the third. And then it's going to factor into a minus b. Notice how the first 2 match. Okay? And then the second part is a squared. But then it's going to be plus ab plus b squared. So this is the only difference, are the signs. They're exactly the same formula. So if you can remember that, and just get the signs straight, then you'll be fine. So that was number 3. Number 4. X minus 4 divided by x squared minus 9. And we want to find if, determine the values for which x minus 4 divided by x squared minus 9 is undefined, right? So we need to find basically our restrictions. So we're going to take the denominator only. So only work with the denominator. And set it equal to 0. Because that's what undefined means, right? We want to find when this cannot be 0. This is easy to factor. It's a difference of squares now. Take each one. X plus 3, x minus 3 equals 0. And then we learn when we have this, we can separate each one. And to solve for our linear equation, x equals negative 3, x equals 3. But remember, we want what's undefined. So you need to come back and state x cannot equal negative 3, x cannot equal 3. And those will be your answers. Any questions with this one? Now we need to divide 4x minus 16 over 5x plus 15 divided by 4 minus x over 2x plus 6, right? So we have technically fractions. That's all these are. They're fractions, right? And what do we do with fractions? We keep the first one. We change the sign. So we change it to what? Multiplication, and we take the reciprocal. We flip the second one. So I'm just going to go ahead and rewrite it. So that way we mark our step. We change this. And then we're going to go ahead and flip this. That way we notice the change. Okay? Now, since we're dividing this, all we're going to do now is factor each one, each tops, and then we're going to cancel like factor terms. If there's one on the top, one on the bottom, we're going to go ahead and cancel that. Okay? So let's do each step, right? We have GCFs again. We have GCF of 4. We take that out. We're left with x minus 4 here. What's my GCF for the bottom?
5.
And I'm left with x plus 3 times, right? And I saw 2x plus 3. And I'm going to leave this like this, but I'm just going to put it in parentheses so that way I know they have to stay together. Okay, a lot of times we don't keep them together. So now we're going to start canceling. Well, right away we can definitely see what? The x plus 3. That's gone. We can definitely cancel the x minus 4, the 4 minus x, but we have to be careful. Why do we have to be careful?
There's a negative sign before the 4.
Exactly. These are opposite terms. And when you cancel the opposite terms, you get -1. Okay? So we are going to cancel these. And you're just going to put -1. And you can put that -1 anywhere as long as you have one negative. Okay? If you put 2 negatives, then what happened? You turn your answer to positive. You completely change your answer. Okay? So we need to be careful with that. So now let's clean it up. Right? We need to write one single fraction with these. So we're actually not done. We can't cancel the 2 and the 4 because they're both on the numerators. So don't cancel those. What you can do is multiply them. So do 2 times 4, which is 8. And then 5 times -1, which gives you your negative fraction. So -8/5 is your final answer for that. Number 6, we need to add and simplify. X squared minus x minus 12. Well, just like with those, we're going to factor. I don't know if you noticed the common theme with the entire class is what? Factoring, right? So, just like here, we're going to keep on factoring, okay? So, factor all the way down. So, x plus 3, x minus 3. But these are easy factors that we tend to notice, right? Here, we have an x and an x. Our signs, the only way we can get this possibility of signs is have a plus and a minus. Now we need factors of 12, right? The only way to get factors of 12 to have a 1 here is what? 3 and 4, right? 3 times 4 gives me 12. When you subtract them, you get a 1, correct? Now, the sign here is negative, so your bigger number is always going to match that sign. Okay? So we have all of our factors. Since we're simplifying, and we have fractions, it's best to find the LCD, our least common denominator. Okay, now, is there any easy way that you want to do it, or is it just best to take your first fraction and plop it right in your LCD? Because we're going to build ours.
I don't know.
You don't know? Okay.
I would say.
You don't know? Yeah, okay. The best way to build your LCD, right? Take your first fraction. Look at your denominator. You know you're going to have to include those factor terms. So put it here.
So we're just finding the least common factor. So it would be.
Now look at here, right?
Yeah.
Now here, what do you have already in your LCD?
X plus.
You already have the x plus 3, correct? And you have one of them. So it's already there. You don't need another one. What do you have the x minus 4 in your LCD over there? No. So we need to add this to it.
Okay.
Okay? This is how we build our LCD. That's just building our LCD. Now we need to go back to our fractions, because when we had just simple number fractions, right, those were easy to find the common denominator. You found the common denominator, and then what did you do? You rewrote them, correct? Now we have to rewrite these, so that way they look like this. So now go back to here. What's missing from your LCD in this one? The x minus 4. So whenever you have fractions, whatever you put to the bottom, we also have to put on top. Exactly. I saw the fingers put up there. Okay? Very good. Do the same thing for the second one. What's missing from your LCD here? The x minus 3. So you're going to put it on the bottom, and you're going to put it on the top. So now you have the same denominator. Now, some students do it all in one step, but I want you to see what's going on. You're going to rewrite your fraction using just the same denominator. All you have to do is have one single fraction now. Because since this denominator is the same, this denominator is the same, you can just have this all together. Okay? Now we need to clean it up. Alright? We're going to see if we have like terms. Well, how do we do that? Well, a long time ago, all we do is what? Distribute. We can distribute this together. So that's 2x minus 8 plus 10x minus 15. Still all over your LCD.
So you're distributing 2 to everything?
We're distributing the 2 to this term, right? So 2 times x is x. 2 times negative 4, that's how we got the negative 8. And 5 times this is, is 5x. And then this times negative 3 is negative 15. Now, don't FOIL this, and then don't have to worry about foiling it. Just keep bringing down your LCD. Okay? And now you can combine like terms. Now it's easy to do, right? Because what's 2x plus 5x? And negative 8 and negative 15. Oh, no, see, gotta be very careful. Oh. You have to remember the signs are the same. We add and keep the signs. That's gonna be what? Negative 23. And all over your same denominator. We keep it this way just in case. What if this was the numerator was able to be factored? Factor it. So that way to see if you can cancel like factor terms. Okay? So if you're able to factor the numerator, please do, because we always want to simplify. Okay? Any questions with number 6? Is it a little bit better? A little bit? Yeah. Oh, good. That's great. So now, with number 7, we're going to use our LCD trick. That's why we did that one first. Okay? Because we have a double fraction here. It's a complex fraction, and that's all it is. It's just a fraction on top of a fraction, but it's with an addition. Okay? So you're adding 3 plus 7x divided by 1 over xy plus 2y. The easy way to do this is use your LCD method, just like the one you did there. Okay? So you're going to look at all the denominators, only the denominators within the fraction. Right? Is 3 a fraction? No, 3 is just a whole number. This is a fraction, so you look at that denominator, and you look at this denominator and this one. That's what we're talking about when we say look at all the denominators. Okay? So we're going to do the same thing. We're going to build our LCD. And we can see here that what is our LCD? An X. And here we need the Y. And that's going to be our LCD. Alright? That's how we build that. Now it's going to be a little bit different from that one. Now we're going to take our LCD and multiply to all terms. Okay? You multiply to all terms, and we're going to write this as a single fraction. That's what's going to be nice about this. It's going to clean up very nicely. So we take our LCD, throw it right in front, and throw it right in front here. Okay? Now, multiply it times this, right? Do we have a denominator here? No, right? So it's just going to be 3xy. Now come here. We multiply this here. And actually, the x's cancel. Do we see that? So you see when we multiply this times this, our x's can cancel very nicely.
Because we could technically put that over 1, right? Just so they're not like a denominator technically.
When we multiply this, right? That's what we're doing. You put that over 1, right? And what happens? Your x's cancel. And you're just left with 7y. And that's what you're going to put here. Plus 7y. Okay? That was just the numerator part. What do we have to do? We have to do it to the denominator again. Because we said we have to multiply it to all terms. So now, if you need to do it on the side again, just like how I did it, right? X times 1 over xy, that actually cancels out, leaving you 1. Times this, well here, our y's are going to cancel, and leaving you just x, and you have to multiply that 2, so that's going to leave you 1 plus 2x. Okay. And when you look at this, you see if you can factor, which I think you can factor out the y, but looking at your answers, they just leave it like this. Okay? So always look back to see if they want it factored or if they just want it like this. Okay? Or x plus 1 over 4. So now we're going to solve. Minus 2x plus 3 minus 3 equals 7 over 12. Well, again, we have fractions, right? So we're not going to go ahead and try to rewrite that and stuff like that. Because what have we learned in our classes? Get rid of your fractions. We can get rid of our fractions by your LCD method. See how our denominators canceled out here? So let's use that again. What's going to be your LCD for this one? 12. So you see how we pull the biggest one that can divide into everything? That's how we do our LCD. Now we're going to do a big distribution. Why? Because again, we need to multiply to all our terms. You got to remember that. So, this is just actually division, right? Think about it. What's 12 divided by 4? 3. Okay? That cancels. This is the reason why we're using our LCD. What's 12 divided by 3 now? 4. So that's going to cancel, leaving you 4, which you're going to multiply by your numerator. Okay? Now the last one. What's 12 divided by 12? 1. So 1 times 7 is just 7. I'm not going to write that. Okay? Could we solve this now? It's a a lot easier to solve now that we got rid of the fractions, right? It's just straight distribution, basically. Do we see that? That's going to be 12x plus 3 minus 8x minus 12 equals 7. All right? I just distributed. Right? Our science program looks good, right? From here, you can combine any which way you feel comfortable. You can do it all in one step, right? We can do 12x minus 8x, which is 4x, right? And we combine like terms. 3 minus 12, which is negative 9, right? Where's the question?
Why is minus 12 and not positive 12?
Because what's negative 4 times positive 3? Okay. Equals 7, right? Now just do what you normally would do. You add the 9, which is 16, divide by 4, which gives you back 4. To f of x plus 11, right? And they tell you what x is. They're just letting you know that this is in what? Function notation. It's easier for us to write it that way. So instead of saying y equals 6x plus 11, they just replace this. This means y, right? So it's just a nice, easy, clean way to write it, because wherever you see an x in your equation, what do you replace it with? Negative 3. So 6, I'm going to times it by negative 3, which is just negative 18 plus 11, right? Which my final answer is just negative 7. But it's just seeing what you're replacing it with. 10. I'm going to write 10 right here. So we have ordered pairs in our solution set. Oh, let's write the correct ones. And finally, 3, 6. And they want to determine if the relation is a function. And what do we need to look at? Which values do we need to look at in order to determine if it's a relation? Which one? So we look at x values only. And what's special about the x? Can we have repeating values, or they can only repeat once? They can only appear once. So, what's going on here? So is this a relation? No, because we have 3 here, and it appears here again, so it is not a relation.
But the y's can.
The y's can, exactly. So when you have a relation, and let's say for really quick purposes, if you have 2, 1, negative 3, 5, and 0, 1, this is considered a relation because x's appear only once, but your y's could appear multiple times, okay? But not your x's. So this is a yes, that's a no. Okay? So now number 11, 64 over 27. With our exponents, negative 2/3. Okay? Now, we need to fix our exponent. It needs to be positive. Now, the easiest way to do it is just to flip or take the reciprocal of the inside fraction. That makes this portion positive. Just by flipping the inside. It's a neat trick to remember, okay? You don't have to do any other special things, okay? Just flip that. But now you have to keep going, right? We recognize that the bottom portion, which is the denominator, right, represents the radical. So this is a cube function. After you take this, after you simplify it, then you take your answer and you raise it to the power of 2. That would be the easier way to do it. Okay? You can write it a different way, but then you would have to worry about squaring it first and then taking the cube root of it, and then you get into really big numbers. So take the cube of this, which that's going to be 3. This is going to be 4. Wasn't that a lot easier by knowing that? And now take the squares of that, which is going to be 9 over 16. Any questions with any of these so far? So 12, we're going to add, or we're going to just find the operation of our radicals. So, can we just add these? Or do we have to treat them like our variables? We have to combine like terms, correct? So they have to be the same inside the radicals. So in order to do this, simplify them first. See if you can break them down. Right? I'm going to break this down automatically to 4 times 2. And when you break them down, look at your radical. We know this is a square root because there's no number. So I found factors that one of them is a perfect square. Okay? So go ahead. We're going to take square root of 4 out, which is 2, square root of 2. Okay? Now, the reason why I said that earlier, right, find factors that are perfect squares. Because 18, right, we have factors of what? 6 and 3. Are any of those perfect squares? No, it's not going to help us. So exactly what you had said. 9 times 2. Because 9 is a perfect square. We can take that out and give us 3 square root of 2. And now we have exactly the same radicals that allows us to add. I call them their coefficients. I treat them like their coefficients. Okay, we can add them. So just add 2 plus 3, which is 5. And keep this the same. Don't add these. You can't do that. So just bring them together. Okay? But we're dealing with what? Our complex numbers, right? Doesn't matter. Still FOIL it out. Still FOIL it out like you normally would, right? You're going to take your first, which is 36. If you see the trick already, go ahead and do it. But if not, work it all out, right? You're going to do your outer, which is positive 12i. Do your inner, negative 12i, and then do your last. So that's going to be negative 4i squared. Now, what happens here? When we combine, treat these, right? Treat them like regular variables. They're like terms. You can add them together, and what happens? They cancel. They're gone. So you have 36 minus 4i squared. But we learned in our class that I squared is actually -1. Okay? So we can rewrite our expression and perform this operation. So actually, 36 plus 4, our final answer is just a single number of 40. Just because we have that I squared.
So it's only if it's I squared.
Only if it's I squared, yes. If you have just an I, then you can't do that, no.
And no other variable?
No other variable, just an I. Because your I came from a negative square root. That's where that came from. Now, unless if you want to get into ease and stuff like that, but that, yeah, I didn't think so. That's in a whole different other level. Let's get into graphing. So we have y greater than x plus 2 and x less than 1. So what's nice about this is they actually have it, the first one, in a very nice setup for us. When you're given two inequalities, it's a system, right? We have to graph it on the same plane. So when you're given that, make sure you graph it on the same plane. Use whichever method you're comfortable using. I am very comfortable with the slope-intercept method, where it looks like this. Because we know that B is our y-intercept and M is our slope. Okay? So looking at our first one, it kind of looks that way, doesn't it? Kind of looks this setup, where it solves for y, so I can just quickly plot my y-intercept, which is what? 2. So I can go to 2, and now my slope is anything in front of the x, which is 1, but I'm going to put that as a fraction, 1 over 1. And slope is rise over 1, of course, right? So we're going to go up 1 and to the right 1. Now, when I graph my line, I'm going to be very careful. It's just y is greater than. It doesn't say equal to. So it's a dotted line. So make sure that you have a dotted line. Okay. And now we need to graph our other one. Well, actually, let's shade it. Okay. I usually shade at the end, but let's shade this one. You can use either testing points, or since it's in this setup, you can say that since y is greater than, your shading is going to be above the line. So you go to the line and shade above. If it said less than, then you shade below. But only if it's solved for y, you can do that. If it's not solved for y, you're going to have to use testing points. And what are testing points? Well, that's just grabbing any ordered pair, right? So let's say if you want to grab 2, 2, right? That's your x, that's your y, right? And plug it in. Plug it into the actual inequality. So that's going to be what? 2 is greater than 2 plus 2, which is 4, I heard. Is that true or false?
False.
It's false. Our testing point was right here. So you're going to shade away from it. Okay? You can't, if it was true, then it will shade towards it. But it's false, you have to shade away from it. So it's all this. Okay? And where is it? Is it above the line? Yes. And that's what we had stated originally, right? So either method works.
So we're not looking at the bottom one, the x.
We haven't done that yet.
That's what I always get confused
Yeah,
with.
we haven't done that yet. Yeah. Now, x is less than or equal to 1. That's a special kind of line. It's a vertical line. And we know it's a vertical line because, first of all, it's an x-intercept. It's the x-intercept at 1. Okay? And there's no y variable. So it has to go through the x, and it's going to be a solid line. And it can't touch the y-axis because there's no y. So, and if you only have an x variable, it's a vertical line. If you only have a y variable, then it's a horizontal line. Now, again, you can do testing points, right? Let's grab the testing points of, let's do 3, right? 3. Is 3 less than or equal to 1? No, right? So then you need to shade this way.
Away from the point.
Right? Away from it. Do we see that? So we're shading this way. And notice, I am going to stop right there. Because here is where the overlap is. And that's all that matters. The overlap. Okay, with these. So when you shade, the answer is the overlap. Okay? Where they share the shading. So we need to rationalize the denominator, right? So we have two terms here, so we just can't take square root of 3, top and bottom. We have to actually consider the entire denominator. So let's just use the conjugate, which is what? The opposite term, right? So we're going to do 8 plus square root of 3. And we do it on top as well.
So we're multiplying?
We multiply. We're going to multiply. Notice, whatever sign you have here, it's just going to be the opposite. Okay?
Okay.
Because now when you do your multiplication, right, we can multiply your 5 if they do that. So that's going to be 40 plus 5 square root of 3. 8 times 8, 64, correct? Now, when you're doing your radicals, if you have a square root, you don't have to do it necessarily all the way through. Just note that when you have exactly the same number, right, square root of 3 times square root of 3, which is what, square root of 9, take it out, you're going to get exactly the same number as the inside. You're going to get the radical, okay? So you do square root of 3 times square root of 3, right? Square root of 3 times square root of 3 is square root of 9. And that's how we got that, okay? Yeah, I saw your face.
And we go with the negative sign.
You go up because what's negative times positive?
Negative.
Negative, okay? Now, clean that up, right? Don't just leave it like that. So it's going to be 40 plus 5 square root of 3 over 61.
Is that the answer?
Yes, it is. But notice what they did. They left it like this. The first part, they didn't distribute the 5. So it looks like this. 5, 8 plus square root of 3 over 61. So that's what I mean. Look to see what you have. If you did too much work, then just factor it back out. So we're going to 16 rationalize again. 2 square root of 3 over 2x, right? But now, we don't have a square root. What do we have? We have a cube root, which is a little bit different, okay? There, actually, it was actually kind of good that we wrote it out, right? We needed to multiply the square by itself to make sure that we were able to take it out, right? Now, same kind of concept with the cube root. We need to multiply by the cube, but we have to make sure that number is a cube root, right? So we already have a 2. So we're going to multiply this 2 by what number to make sure we can factor it out? Not by 8. By actually 4. Because what is 4 times 2? Isn't that going to give us 8? And what is the cube root of 8? 2. That gives us it out, right? Now, that takes care of the number. What about the x? We also have to get that x out of there. Well, let's just put x squared. Because if we remember our power rules, when we multiply our variables, we add exponents. So 1 plus 2 will give us x to the cube. Okay? Now, that's what you did to the bottom. Remember, whatever you do to the bottom, you have to put on top. Okay? So, that way you can see exactly what you did after you multiply everything together. This is the whole reason for it. Okay? Because now, after rationalizing the denominator, you can actually calculate this. And this just becomes 2x. That was the whole reason for doing that. Okay. Now, are you done? Can these two cancel?
Can they?
They could, because this is a multiplication. It acts like a factor term. As long as you have something times something, you can cancel a like factor term. If there's a plus or minus in between, you can't cancel them out unless you take it out. Okay? So now, you can cancel these 2's out and leave your answer in simplified forms. Just because we have multiplication. Multiplication and division makes things a little bit easier than addition and subtraction. What is the system of linear inequalities represented by the graph? Okay, so we're going to have to work backwards here, okay? So you have to look at your graph. Oh, you don't have it? Okay. No, it's okay. I'll try to draw it as accurate as I can. So you're given a graph. And we have a dotted line, right? And then we have a solid line going this way. And then the shading is here. That's our graph, right? Now, actually we still have it up. Our slope intercept, we're going to work backwards from there. So let's use this one first. Okay, let's do that one. Looking at this, our intercept, our y-intercept is actually -1. That's our y-intercept. Okay? And we know that it's going to be either less than or greater than. There's no equal to sign. Why? Because it's a dotted line. So that dotted line tells us we either have this or this. Okay? Now, kind of what I said before. Your shading, if you have it in y-intercepts, in y-intercept form, right? It makes it a lot easier. So, the shading is below the line. Since it's below the line, it's automatically going to be less than. So we already have y is less than -1. And obviously we're going to need an x. So now we just have to figure out what's in front of the x. We know it's positive because why? Is the line going upward or downward? It's going upward. So the slope is positive. Now we just have to figure out, looking exactly on our graph, which is better, we go up 1 and over 1, and it actually hits it right here. So we're here, this is our y-intercept. You go up 1 and over 1, that's the next point that it hits it. So actually our slope is 1. Okay, and that's how we build our lines. So that is your first equation, okay? Now we have to find the other one. And we already know it's going to be y. It's a solid line, okay? But look at where it is. Look at where the shading is, right? The shading is above the line. So it's going to be y is greater than or equal to. So if the shading is above a line, it's going to be greater than, okay? Now, if the slope is going downward, it's going to be negative. So we already know it's negative. And the y-intercept, where's the y-intercept? Here's the y-intercept, correct? So that, what is that?
Over it crosses the line.
That's +1. So we just have to figure out what the slope is. So the slope, looking at your graph.
So you figure out the slope by where the lines intersect?
No, we're figuring out the slope exactly where it hits it like an ordered pair.
Okay.
Okay? So I'm looking better on your graph. So I can show you later on exactly on the graph.
Okay.
Because I'm here, it's not to scale.
Okay.
So I'm going to go here, right? I'm going to go 1, 2 down, and then over 1, and then here's your next point.
Okay.
So what did I just count? I went down 2 over 1, which is just -2. That would be the easiest way to find your inequalities, or actually any equations if you're given a graph. Any equations. And actually that's going to be what? You have to be very careful because they make signs and stuff like that. I think it's A. What those are. Okay? Now we're back to factoring. We're back to factoring and we're using to solving. So 18. X squared minus 2x plus 4 equals 0. Now looking at this, you can do this a couple of ways. We know we can't solve this at all, okay? Because 4 is either 4 and 1 or 2 and 2. And we're not going to get 2 in the middle. So this is not able to be factored. So you can either do the complete the square method, or we can use the quadratic equation, which we learned, right? So quadratic equation is x equals -b plus minus b squared minus 4ac, all divided by 2a. So we need to learn to spit that equation out like that, okay? It's going to be very helpful to us, especially in our future classes. It's 4ac. Okay. All over 2a. Right. And if you need to, go back to your standard form of ax squared plus bx plus c equals 0, so you know exactly what represents your a, what represents your b, what represents your c. And now let's just plug them in. So negative. Now my negative is standard. I'm going to plug in 2. That's my b. Plus, minus, square root. Negative 2 goes in here also. Minus 4 is standard. 1 and 4. All over 2 times 1. Okay.
Why is it plus?
Because we're taking a square root, and square roots always have 2 answers.
Oh.
Okay? Don't forget that. Always has 2 answers. So let's clean things up, right? This automatically becomes positive. And then you can work from your inside.
Can you cancel it?
Huh?
Can you cancel it, please?
No. Because of this plus minus. You have to wait and exactly. You have to wait until you see if you can take something out. Okay? So you can't just get rid of it just yet. So that's what? That's 4 minus 16, correct? And then you're going to go ahead, we're going to keep going, all over 2. Well, x is equal to 2 plus minus, that's going to be negative 12 over 2. Yes or no? We're good? Alright, now, we need to keep going. You don't leave your answers there. Not only can you simplify your negative 12, don't forget, we've learned something. I erased it. But you can definitely take out that negative now, right? What does that become?
4.
Becomes an I. An I. I. And I heard, yes, you can definitely now factor, because that becomes now positive 12. 4 times 3. But don't forget, your negative square roots becomes positive by taking out that I. Okay? So, x equals 2 plus or minus. Well, we're going to take out the square root of 4, right? So that becomes 2. I'm just going to put the 2 in front of the I, but behind the plus minus. Square root of 3 over 2. Now it comes back to, sorry, what's your name?
Jamie.
Jamie. So now Jamie. Now, since you have a 2 here, a 2 here, you can cancel it. Yeah. You can now divide everything by 2. So in every term you can do it. Okay? Before you couldn't, because there was no 2 here. Okay? So now rewrite it as your final answer. Put that 1 there to represent that place. Plus minus I square root of 3. If you don't put that 1 there, where did it go? All right? Plus 7x minus 3x plus 2 equals 8x plus 6. This is actually just what? Just recognizing that you can combine like terms, this one. After every hard one that you did, I think you could recognize that you can combine like terms, right? 7x minus 3x, 4x. 4 plus 2 is 6. You can do it all in one step. Equals 8x plus 6. Now, you can go any way you want to go with your variables, right? You can go this way or you can go that way. I know a lot of times we're so used to putting our variables on this side. So go ahead and do that, right? You're going to bring your 8 over here, and what does that become now? 12. Negative 4, right? Got to be careful. You subtract on this side, and it's negative 4x. Bring your 6 over, right? We still have to combine like terms. Negative 4x equals 0. Exactly. You subtract that.
But if I do it the other way, and if I move the 4 to the other side, it will be 4 and not negative 4, right?
Exactly.
How do I know?
At the end, you still should get the same answer.
Oh.
You still should get the same answer. Which is what, by the way?
1, 0?
Which one?
1, 0. Oh,
Overall.
it's on top, the 0 at the
Yes,
bottom. Then
yes.
it's 1. Okay.
With 0 divided by any number is 0. Okay? The only way that it could be 1 if it was negative 4 divided by negative 4.
Okay.
It has to be the same number. If it was negative 4 divided by 0, you still would be wrong. It'll be undefined. Okay? Okay. So, x would be 0. So if you did it the other way, you still should get 0. So you gotta be careful with that, right? Number 20. 2x squared plus 4x equals 9x plus 18. So, when you go ahead and do this, right? Again, equal it to 0. Get it over everything to one side. Your leading term, your leading coefficient of x squared is already positive. So I suggest moving everything to where that is. So I'm going to subtract 9x. You can even move over your negative 18 at the same time, right? So you have 2x squared minus 5x. There's no like term for negative 18, so you just bring that over. All of this was gone, put that 0. Now, you can factor it, or you can just go ahead and use the quadratic formula. I think by now, everyone's comfortable using the quadratic formula. So you can go ahead and put that into the quadratic formula. I'll just show you how it looks, and then you can go ahead and put that in, right? So it's going to be negative, and you put in negative 5, because the formula's still there, plus minus, now whatever number's here, that's still our same b, so don't go changing numbers. Minus 4, our a is going to be 2, and our c is negative 18. And everything is divided by 2 times our a, which again is 2. So after you clean all that up and simplify, you'll get your answer. Alright?
So I square the negative 5 first, and then we go from there?
Yep, and then you go from there. So this becomes positive 5, plus minus, that's 25, and then negative 8 times negative 18. And then you would add that together, and then you can, I believe, you can take it out of the square root. Okay? (21) 8x to the 4 minus 18x to the 3rd minus 5x squared equals 0. We'll get practice with this one using the quadratic formula again, okay?
What's the answer for number 20?
It should be A. Back to looking at all your terms again. What do they all share? In x. In x, right? Right. X, as you said, to the second power. Take that out. X squared minus 18x minus 5 equals 0. Okay. Now, since this is actually considered two-factor terms, okay, you can definitely equal that to 0. Okay. Now equal this to 0. But we still have a quadratic equation, don't we? And is this by itself? No. How do we get this by itself? Do we remember our square root property?
Yeah.
No? here it is. You take the square root on each side. X equals, what's the square root of 0? 0. 0 doesn't have a sign, right? So this is just one answer. So we're done with this side. Okay, so a lot of times students forget about this one. Okay, now we need to finish up this line. Let's get practice with that quadratic equation, right? So x is going to equal negative times negative 18 plus minus. Well, I'm going to put in negative 18 to the second power, right? Because that's my b. So my b goes here, and my b goes here.
Which one is 8?
This is a, right?
This goes A, B, and C.
It's a, b, c, right? See? A, b, c. Okay? So my a is going to be 8. My c is going to be what? Negative 5. All over 2 times 8 again. Okay? So I'm hearing the fingers work. What's the 18 square? No, it's not 9.
2. No. 4.
No, what's 18 times 18?
Oh, 324.
324, right?
Do you parentheses first, then 8 times 5, and then
You can do that. You can do 8 times 5, which is what? It's negative 40, right? Negative 40, and then negative 40 times this would be positive 160, right? And then that's just over 16.
Negative 160.
But you had a negative.
Negative 4, so if I can't do it like straight across.
You can do it straight across. You can do negative 4 times 8.
Is negative 32.
And then negative 32 times negative 5. Right? Positive 160. Good. Now we add these together, which is going to be 4, that's going to be 8, that's going to be 484. Right? See if you can take the square root of 484. Always check to see if you can do that. Which is what? 22. So 18 plus or minus 22 over 16. Now, we're going to simplify this. This is why I wanted to do another one so you ladies can see it. Because a lot of times, you might forget this step. Right? We have plus or minus, correct? Let's separate it. Let's do x equals 18 plus 22 divided by 16. And 18 minus 22 over 16. Because that's what the quadratic equation is really telling us, right? So, what's that going to be? That's going to be 10. That's going to be 40 over 16. And we simplify this, correct? We always simplify. Don't ever leave your answers like that.
5 over 2.
Huh? 5 over 2, right? Remember, that's 40. That I corrected my 6. It's not a 6, it's a 0. 18 minus 22, that's going to be negative 4 over 16, which that just breaks down to negative 1/4. Now, put all your answers together, right? So, in your solution set, your negative comes first, negative 1/4, then you have your 0, and then you have your 5 over 2. And you have your 3 answers. So don't forget your 0. That was long.
The 0 can be the first?
Huh?
Or negative comes first.
Yeah, well, technically for me, I put the negative, but they didn't do that. So it's D. It's D. It's still the same. It's still the same numbers. They just didn't put it from, you know, the least to greatest. Okay, I put it from least to greatest. 22. I'm not going to write the problem, so I'm just going to read it. Okay. The hypotenuse of a right triangle is 8 inches longer than the shorter leg. The longer leg is 4 inches longer than the shorter leg. Find the length of the shorter leg. Right away, what do? They told you have a right triangle. Draw it. Okay, so that way you know exactly what to do. Whenever you hear right triangles and stuff like that, automatically you're going to write the Pythagorean theorem. Right? A squared plus b squared equals c squared. That's how we're going to tackle these problems. Now, go back and reread it, right? The hypotenuse, which is what? Is always opposite the right one, right? The right angle, the hypotenuse is always opposite. So here's your hypotenuse, always. The hypotenuse of a right triangle is 8 inches longer than the shorter leg. The longer leg is shorter than the shorter leg. So we don't know anything, right? Your legs, A or B, one of them's a shorter leg. We don't know anything about it. Since A and B are on the same side, just make one of them the shorter leg, since they can be the same. So if you want, you can make this one your X, right? And now you can start building everything from there, right? So your hypotenuse is 8 inches longer. So go back to here, X plus 8, okay? And then the other leg, right, this is the longer leg, is going to be 4 inches longer, so that's X plus 4. So now we know exactly what each one in theory is. Use your formula to find it. So A is X plus 4 squared. That's what we wrote here. We don't know what this is at all, so that's just going to be X squared. And then this is 8 plus X squared.
Do you have to put the X, the B in parentheses, or do you do it as X?
You can just leave, well, you have to remember that's what it was, and then it became X squared. Okay. Now, depending on how you multiply this out, you can do it whichever way. You can FOIL it out, or you can expand it. I use the formula, so whichever way, just do it that way. So I'm going to go ahead, right? I know this is square. This is going to be plus 8x, and then that's 16. So after you FOIL it out, that's what you get here. Okay? Plus 8x. Again, I have to FOIL this out. So I get x squared. I get plus 16x after I FOIL it out, plus 64. So after I expand everything out and multiply, that's what we get. Now we just need to combine like terms and see what's going on, right? So here, I can do 2x squared. See, x plus x is going to be 2x squared. I don't have any other like terms. So now we just need to start what? Bringing stuff over. So bring stuff over. I'm going to bring my x over, my x squared. I'm going to bring it to here. Bring over 16x. And look what I'm doing. I'm putting them what? With its like term. I'm not just putting them all over the place. I'm putting them where they need to be with. And then my numbers together. So all of this cancels out, leaving me with 0. Okay, we want that 0. And that's x squared minus 8x minus 48. Now, do we have to do the quadratic formula for this one? No. This one's an easy factor to do. Put your two parentheses, right? Do x minus 12, x plus 4. Okay? So if you can factor it really quickly on your tests or exams or whatever you're doing, factor it. Because actually that's the quickest way to do it. Okay? If you get stuck, then resort to the quadratic equation. Okay? Now, are we done? No. You have to take each one, equal it to 0, and solve. Okay. Now, we're doing a measurement, right? Do we keep both these answers, or do we reject one of them?
Reject the negative.
We reject our negative. So we only have our one answer of x, which, by the way, what does x represent?
B.
The b, right? Which we determined was the short leg. So we got our answer. Okay?
So it would be x equals 12.
So it would be x equals 12. We have to read the problem. What if they wanted the hypotenuse only? Then you take your answer and put it in here and would add 12 plus 8, which would give you 20. So it really depends on what they want. Okay, so be careful because I think the answer is there too. Okay? Yeah, it is. Okay, so if you do too much work, then you might get the wrong answer. Okay, so pay attention to what they're asking for. Okay. 23. Find the slope of the line determined by the points. Slope, right? Between 2 points. So that's just our slope formula of y squared minus y1 over x2 minus x1. Yep, that's the slope formula for 2 points. Okay? Always remember, put your y's is always the numerator and x is the denominator when you're dealing with slope. Now you can just plug in your points. And I'm just going to quickly do that. Negative 5 minus 2, 5 minus negative 3, okay? Remember, the minus is from the formula. So I have negative 7. This turns into a plus. This actually turns into a plus 3. So we have negative 7 over 8. The final review is, I think, 35 questions. So when they
My
come
last
back,
one was like 90, so.
yeah, when they come back, we're gonna have to shoot them back out. We need to go 2 hours. So 24. 24. We want to write the equation of a line that contains the point 2, 7 and perpendicular to the line 4x plus 3y equals negative 7. Okay, so we need to find the slope before we do anything else. So we just need to find the slope.
Can you put it in standard?
We have to first put it in slope intercept to find the slope. So we have 4x plus 3y equals negative 6. So we're going to put it in our point slope, not point slope, our slope intercept first, like how we did before, what we talked about, right? So I'm going to move this over. I just moved over my 4x. Divide everything, what, by 3. So y is equal to negative 4/3 x minus 2. Now your slope is negative 4/3. Okay? That's your slope from the equation. Your new slope that we want to have and we need it to be perpendicular, right? If it's already negative and your old slope is going to be positive, and it's going to be the reciprocal of it, okay? So your new slope that you need is positive 3/4. So you just didn't have to work. We're not even done, all right? Now, we're going to use point slope formula, which is y minus y1 equals m times x minus x1. To help find that new equation. The reason why we're using the point and the slope formula, because we're given a point and we have slope. That's why we use it, okay? So, y minus 7. I'm using now the information that was given, the point. I'm using the new slope, okay? I don't need this anymore. Don't go back to it. Use the new slope. 3/4 x minus 2, okay? Now, go ahead, do your distribution. Y minus 7 equals 3/4 x, right? If you need to, put this over 1, because you can see what? That becomes minus 3/2, okay? When you multiply this times this, you can go ahead and start now moving things around, because all your answers are in standard form. And standard form is ax plus by equals c. So now, move your 7 over, right? You're going to go ahead and add 7. Okay? And you need to bring that x back over. So bring your whole fraction over. Negative 3/4 x plus y equals negative 3/2 plus 7. Now notice I'm not even touching anything yet, right? And the reason is, I know it's been a while, because this is probably the first few lessons in the class. With standard form, your leading term of x, right? That can't be what? It can't be negative, and you can't have fractions. Exactly. We've seen the number. Yay. So we need to multiply everything by, not by 3, by negative 4. So let's multiply everything by negative 4, which actually happens to be your what? Your LCD anyway. So we're going to use our LCD method. We've been using that all day.
So it would be, we would have to multiply by the LCD?
Yeah. So now let's do our LCD, right? So that becomes positive. Our 4 is gone, leaving us 3x. And we do it to all terms. See, that comes back in all terms. Minus 4y. Well, this divided by this is just 2. And 2 times 3 is 6. Minus 28. Now, isn't that easier to do than the fraction, right? Which is what? 22, yeah, right? So 3x minus 4y equals 22. Negative 22. No, forgot the sign. I had it there, I just forgot it here. Let me rewrite that. I'm sorry, what?
We would just rewrite that because it's in standard form.
The last answer here, this is considered standard form, right? Because we don't have fractions. And our x term is now, is that positive now, or is it still negative? Positive. It's positive now. Okay. And it's perpendicular to the line because we use the new slope. 25. Well, they want us actually now to determine whether the two lines are either parallel, perpendicular, or neither. So guess what? We're going to have to find the slopes of each line. So we're doing the same thing again. So 3x minus 2y equals 6, right? Let's find the slope by moving our x term over and what? Dividing by y. So that's going to be positive 3 over 2x minus 3. We divided everything by 2. And your slope here is 3 over 2. Now your other line, 2x minus 3y is equal to 6. Again, find the slope, just like you did. When we divided, right? So we have y is equal to positive 2/3 x minus 2. So our slope is 2/3. Now, yes, it's a reciprocal, correct? But is one of them negative? No. So it's neither of them. Because of what I just said, one has to be negative.
Wait, so
like over here, this was negative 4/3.
because yeah, but
Okay.
I messed up the when I divided through by negative.
Careful with those signs, okay? Because then you would have gotten that one wrong after you did all the work. Okay? If they were exactly the same, if it was 3/3, 3/2, and 3/2, then it would have been parallel, no problem. But here, they want you to make sure you understand that one of them has to be negative. Um, 26. Which of the following is the graph of 3x plus 4y equals 12? Now, again, for me, slope intercept is the easiest way to go, or you can find your individual intercepts, but we have been so much solving for y, let's just keep in that same mind frame. So, let's go ahead, move our x term over, right? Now what? Solve each one by 4. So that's negative 3/4 x plus 3. And this tells you what? Your y-intercept is equal to 3, and your slope is equal to negative 3/4. So you have a line that's going downward. So you already know how your line is going. You're starting at 3. That's what we wrote down. Now, depending on how you write your slope, you can go either down 3 and then to the right, or up 3 to the left. It all depends on how you do it. I tend to go down 3 and then to the right 4. And then you draw your line as best as you can. Missed it. But that's how it should look. Yeah, I'm still.
You still muted?
Yeah, it looks like I'm going to go to 4.
Okay, I'll come back.
Okay, thank you. So that was what, 26. Any questions with this one? Is this one good? Right, okay. So 27, we need to divide. Now, what's nice about this one, you're dividing by what? A monomial, correct? So you could actually separate each term. You can put it in as, instead of having that whole thing over that one fraction, you can take each term and separate it to have 3 individual fractions. So I'm just going to rewrite it showing that. 5m to the third divided by 5m squared minus 9m squared over 5m squared plus 10m over 5m squared. That's what we mean by that, okay? Now you can just do your division as is, like you normally would, right? That cancels. What do we do when we have power rules, when we have division? We subtract, right? So that's going to leave you with m minus, well, 9 over 5. Your m's cancel here. Now be careful with this one. Now, look in here. You have your variables and you're subtracting, right? But which one cancels? The top one cancels and you're still left with 1 on the bottom. So you have 2 over m. Okay? So just remember that. Or subtract, right? 2 minus 1. What's 2 minus 1? It's negative 1, right? But which one's bigger? Is the bigger one on the bottom or the top? Put your answer where the bigger one is, always. And you'll never get that wrong. 28. Well, we want to find our intercepts, right? But they want to find a specific one. They want to find the x-intercept. So since they want to find our x-intercept,
Set y to 0.
we're going to set y to 0, exactly. So when we set y to 0, this disappears. So I'm just going to put my hand over that, and we're going to pretend that's gone. And all we have left is this. And we solve for it. So x is equal to -3. That's exactly how we would do that. Okay? Oh, 29. Let's say we remember, like about an hour ago, this question. We want to graph x equals -3. What type of line is that going to be?
Like, oh, wait. Okay. Are going down? Is it like vertical or horizontal?
It's going to be a vertical line. Okay? Because think of it, right? Look at that right there. You only have an x answer, so it's an x-intercept. So when you're graphing this, and it's not just a point at 3. If you put a point at -3, that's incorrect because you actually have an equation. So it's a line going through that intercept. Okay? And it's a vertical line. So just fall back to your intercepts. Well, hey, I only have an x-intercept. So I'm going to go to my x line, put that there, and go through it. Okay? Or vice versa. If I have a y-intercept, go to your y-intercept and go through it. Okay? Not right on it. Okay? I see sometimes that. Let's see. 3x squared plus 2x equals 1. And we want to solve. Well, we're back to fractions again. Do you think we can just solve as is or just pull the LCD method? Let's pull our LCD method. It's worked for us before. In this case, it's going to work again. So the LCD, we look at our denominators only. And when we have variables, just pull the biggest exponent. So your LCD is x squared. When we have these, what do? We multiply it to each and every term, right? So when we do this, again, we multiply it to every term. And what happens? The x squares here cancels, leaving you just 3. Here, just 1x cancels. So when you multiply this times this, 1x cancels, leaving you 2x. And 1 times x squared is x squared. Now we need to solve. What do you think we do? We're going to get everything to one side. Your leading terms on this side, is it already positive? We'll leave it there. Move everything to the opposite side. I know we're kind of not used to doing that, but sometimes we're just going to have to work it that way. And this is an easy factor, right? Factor it. X minus 3, x plus 1, and it's still equal to 0. Since it's still equal to 0, what do? Just separate them. X minus 3 is equal to 0, which that's 3. X plus 1 is equal to 0. X is equal to negative 1. So there are your answers.
I always forget how to factor once I get to like the x squared minus 2x minus 3. I don't know why it always like goes away. But I always so whatever when you multiply it has to get negative 3, and then when you add them it gets negative 2.
Exactly.
I don't know why I forget that.
31. Now, y to the 1/3, 3 to the 3 over 6. Okay, I'm just rewriting it that way. And y. Okay. Now, if you want to, you can simplify this to 1/2, but that's not going to get you anywhere. Okay. I would go ahead and rewrite this as the same power, same denominator. Okay. Now, why do I say that? You're like, well, wait a minute, we're multiplying. But what are you multiplying? You're multiplying variables, right? And when we multiply variables the same base, we add exponents. So technically, this is what's going on. That's what's happening. So we need to rewrite this 1/3 for it to have the same denominator. So go ahead, times 2 top and bottom, right? So that would give us 2, 6 plus 3 over 6. Again, that's still over y. We're not even touching that yet. And that's going to give us 5 over 6 over y. Now we can simplify with our bottom, right? Now, this is to the power of 1. Do we agree with that, right? Can we convert our 1, I'm going to put it 1 over 1, to the same denominator, right? By timesing it what? By putting it 6 over 6. Because now what can we do? We can subtract our powers, right? So since we're going to subtract, kind of like what I mentioned earlier with this one, right? If we subtract, just do your normal subtraction and keep your answer where the bigger power is. See how since this one was a bigger power, we kept our variable down here? Where do you think our variable is going to end up? On the top or the bottom?
Top.
Which one's bigger? It's 5 or 6? 6. So your answer is going to end up on the bottom. And then what's 6 minus 5? Isn't it 1? So it's going to be 1, 6. Don't leave this empty. Just put 1. With fractions, you have to put a 1 in an empty spot. Okay? Don't put 0 because then your whole fraction became 0. Just put a 1. So, x plus 5 square root to the second power equals 3. Well, we're going to use something we used earlier to get the second power by itself, and that is the square root property. So take the square root to both sides, but we have to remember whenever we take the square root, we always have two answers. So it's going to be plus minus square root of 3. Okay, so whenever you take a square root, Always get in the habit of putting plus minus. Now, let me take that out of the quantity. Get x by itself. Move over your 5. Put that in front of the plus minus square root of 3, and you're done. That's your answer. So these, if you keep them that easy, you'll be done. Let's see. 33. We're almost done. X plus y equals negative 5, and negative 2x plus y equals 1. We need to solve the system. Okay? When you solve the system, look to see what's easier to do. In this case, elimination is easier to do. But you need to fix the first one. How do you fix it? Well, I'm going to multiply everything by 2 because I have a negative 2x here. So look what happens when I multiply everything by 2. So I get 2x plus 2y equals negative 10. And I'm not going to look at that anymore. When we do the elimination method, we always add our two equations together because that would be easier to do. And what happens when I add these two together? They're gone. They're gone. They're eliminated. And that's going to give me 3y. And that's going to give me negative 9. Look how nice and easy that became. Solve for y is equal to negative 3. That's half our answer. Okay? Take your y, put it into any equation that you have to find your x. So I'm going to use the second equation. Negative 2x. I'm going to replace my y with negative 3 equals 1. Solve for x. I'm going to bring this over. This equals 2. X equals negative 1. So your answer as an ordered pair is negative 1, negative 3. That's how we do our systems. But what did they only want? I didn't even have to do all that. All they wanted was what? The y. So you could have stopped there. But in case if they wanted the x, you could have done that. This is one I'm not going to write on the board either because it's too long to write. So 34. A rectangular top is 2 feet longer than it is wide, and its perimeter is 20 feet. Find the length and width of the tabletop. Well, they told us it's a rectangular figure, and its perimeter. So what the perimeter formula is perimeter equals 2L plus 2W. Get to remember these, okay? These are your basic formulas. And they already told us perimeter equals 20. Now I'm going to go back and they say a rectangular top is 20 feet longer than its wide. Well, that's going to be my length. So I don't know what my W is, so I'm just going to leave it as W. Okay? Now, go ahead. Let's plug that in. 2 is standard from the formula. Don't lose that. So what's L? You told me it was W plus 2. 2W, that's standard. Okay? Just bring that down. Especially since we don't know what W is. Okay? Now looking at this, don't we have the same variable? It's just a linear equation. Distribute like you normally have. Look at how nice it's becoming. These are just like terms, aren't they? See, 2W plus 2W is what? 4W, right? Let's solve for W. I'm just going to move it over. That's going to give me 16. And when I solve for W, it's just 4. So 4 is my width. I found my width. Now I'm just going going to find my length, and I'm going to replace it. See how I replace it? So the length is equal to 4 plus 2, which is 6. Okay? Last one! Yay! We're going to make it. So, we want to find out what number needs to be added to form a perfect square trinomial. Okay? What that means is we're going to find a completed square method. That's kind of what we're doing. So, we're going to use this tool, if we remember, right?
What is that called?
The finding the nth term in the trinomial, because we need to figure out ax squared plus bx plus c. C becomes the nth term. We need to figure out what that is. And we know what b is. That's what this is. So you see how the b is tied with only the x? So whatever is there, put it in here. So that's 20. Right? Do that little thing inside. You divide 20 by 2, which is 10. And then you raise it to the second power. And it's positive, right? Always take the signs with it. So that's 100. So you are on your way to completing the square. Okay? That's how you will complete the square.
So then we just solve it for them.
We found that number that makes it a perfect square trinomial, right? Because what's the perfect square trinomial?
2.
You take this, that's x, right? Plus whatever makes this the square root of this to the second power. Okay?